Egyptian, Roman. We just started talking about Babylonians and Mayans. I mentioned Mayans, but I haven't even said much about what their stuff looked like yet. Did I tell you what the Babylonian numerals were? All right. Our system is base 10, correct? Because let me do this first. We're about the next two sections, 2.2, the rest of 2.2 and section 2.3 are all hinging on a similar idea. It's this idea of what if our base wasn't 10? What if our base was something else? What if Jeff didn't bring any paper for himself? What would happen then? Okay, I use you. Awkward silence as I wait for things to warm up. There it comes. Look at it. Look at it. How about them Padres? So, I thought I did this, but maybe I didn't. But let me do this first before I show you the Babylonian numerals. Just for a moment, this is going to be really silly, but just go with me. Our number system. I'm pretty sure I wrote something like this down before, but if I write the number 5132, what place is that in? The ones. Tens. How do you figure out each place? What do you do? You multiply by 10. Multiply by 10, yes? So it's not that big of a stretch to imagine what a base 8 system would look like, for example. Right? So before I do that, how would I put this number back together? I have 5 whats? 5,000s. Plus 100s. Plus 3 tens. Plus 2 ones. And of course, if I add that, I get 5132 because that is our number system, and that's what that freaking thing means. So imagine, what about base 8? Just to go ahead a little bit, because what was Babylonians again? Somebody just said? Base freaking 60. Okay, that's weird shit. So let's talk about base 8 for a second. Section 2.3 is going to be all about our numerals, but different bases like base 7, base 12, base whatever. Can somebody just tell me what the places in base 8 would be? So what do I always have to get me started? Does it make sense? It's got to have a ones place. Yes? Well, then what's this? It's not base 10 anymore, it's base 8. 64, good, because how do I get 10 to 100? I multiply by 10. In fact, I really want you to think about this. If I have 9 tens, and I add one more 10, do I put a 10 here? No, right? Doesn't that roll over? Isn't that just like your speedometer? If you get a brand new car, it's all zeros, right? And you start driving, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the next two activates, yes? You guys semi with me? Okay, so if I want to put 10 here, I don't. I put 1 here because now I got 100 because I have 10 tens. So, 1 times 10 is 10 times 10 is 100. And why do I do that? Because once I get 10 of these, I can then roll over to one of these. 8 times 8 is 64 times 8 is... What's 8 times 6? What's 8 times 6? 48. So what's 8 times 60? 480. What's 8 times 4? 32. What's 480 plus 32? Okay. I love you guys. By the way, you will be able to use calculators. Okay. But a big part of this class is algorithms for division, multiplication, all that kind of stuff. So there will be situations where you won't be able to use calculators. Now, this doesn't make any sense to us. Not immediately. As much sense as metric makes. Anyone here born here? If you were born here, you only know the system that's based on the size of the King of England's foot. Right? I thought we had a revolution, but we kept the freaking the measurement system. Do you guys know that? Yeah, it was based on one of the Henrys. Whatever big his foot was, is what they called the foot. Are you with me? And now even the British use metric, not that system. We got our independence, but yeah, we're still going to use his foot. What the shit? All right, sorry. It was all a side note. I'm very sorry. So this is very weird to us, but I want you to notice one thing. If I do this, can you piece together what that number is? This is 1034 base 8. How do you piece together what it means to us? I have one what? I have one 512 plus no 64s plus 3 8s plus 4 1s. So if we had a base 8 number system, this numeral 1034 would mean whatever the hell this is. So what is this? 530, 540? Is that what that is? No, it's not. What is it, Jeff? 24, yeah, it is. 24, no, 28, yeah, 540. So if we had a base 8 number system, so for example, if we had no pinkies, we would have a base 8 number system. You guys see why? Because this is why we have base 10. There's not a damn thing special about the number 10. There isn't. We just happen to have that many fingers. So if we had this many fingers, we'd have a base 8 number system. So let me ask you this. Base 10, what's the highest single digit? In base 10, the highest single digit is 9. So what do you think the highest single digit is in base 8? 7. Okay, good. All this we're going to come back to later. I'm trying to build a little bit of something so we understand base 60 better. So I don't care what base I'm working with. It's relatively easy to convert back to us. So for example, if I had 1, 3, 1, base 4. Can you guys see how to piece that back together into what our number would be? So this is somebody somewhere that has 4 fingers, yes? Some little alien's like, you know. I don't know, that's what they sound like. Take me to your leader. Okay. What place is each of these numerals in? What's this one in? This has got to be in the ones. And since I'm base 4, this has got to be 4s. And this has got to be 4 times 4, 16. And do you see how I can put it back together now? So if there was an alien species that had a base 4 number system and they said, I need this many, I don't know, this many eggs, where we will destroy your planet. And we're like, how many eggs is that? They have a base 4 system. So I could just put that back together. What is it? 16 plus 12 plus 1. So 29. So we got to give them 29 eggs. You guys semi with me? All right. So there's not a damn thing special about 10. The reason 10 has 1, 0 is just because we chose the base to be 10. Different number of fingers, different base. Trust me. Trust me, bro. All right. So, coming back to Babylonian. Babylonians had a base 60. Does anyone remember why? I'm pretty sure I told you why.
Is it because of
It's because the length of a year is roughly 360, and 60 goes into 360. So you see a lot of civilizations having somehow some reference to 360, because that's obviously very important to a society where just to freaking survive, they got to keep track of their crops. Yes? Okay. We do the same thing. We're just not as dire because we got crops all over the place. Okay, so Babylonians. Base 60. So what do their places look like? This will be the what place? Always. Ones gets us started. Makes sense. I don't care what your system is. You got to have somehow some way to represent 1. What's this going to be? 60s. It's already weird. What is the biggest number that they could represent in one place? 59. That's weird. All right, so what would the next place be? 36. 100. Yeah, 60 times 60, 6 times 6 is 36, and then 2 zeros. And by the way, we stole for the Babylonians how we do time. How many seconds in a minute? 60. How many minutes in an hour?
60.
So how many seconds in an hour? 60 times 60, 3600. So they established this system, and then we said, hey, let's use that shit. And they weren't around to say no, so we just, we got it. Okay. So the second level of this is they do not use our numerals. Of course they don't. Because they were around a long time ago. What they use instead, and I thought they said this, but maybe not. They used to chisel into clay tablets. And the end of their instrument they used for that looked like this. And this would mean 1. This would mean 1. The way I'm going to do that operationally is I'm just going to use that. Yes? Instead of drawing a little triangle every damn time. And you'll see why. Because if you got 8 of these, I'd much rather make 8 of those instead of 8 of those. Then they would put like this. They would do that so it would become this. That would mean bean. Why do I keep saying bean? That would mean 10. And you guess how I'm going to represent? I'm going to represent like a less than, like a Pac-Man. So, can someone tell me what number this is in Babylonian? What number is that in Hindu Arabic? Baby, Hindu Arabic. What'd you say? 23. Kick-ass. 2 10s, 3 1s. Is everybody with me? That on its surface is pretty straightforward, yeah? But then if I want to illustrate higher numbers, it gets insane. What if I had to write the number 6,487? I do not want to write. No. So that's why they came up with their place system. So how does this kind of jive together? Our place system, how many digits can we fit in one place? 1. There can only be 1 digit in the tens place, correct? And so forth. Babylonians were like, no, what the shit? They're a little more creative with it. They're like, no, I can pack as much shit as I want to. They just leave a little space. So let's analyze this Babylonian number. Here's a number in Babylonian. What you got, John? Okay. There is a number in Babylonian. Can anyone tell me how many places there seem to be? 2. Beautiful. What places are they? 1 and 60. Okay, let me stop for a minute. You guys with me? So now we're merging these two ideas. I talked about base 60 by itself. I talked about their numerals by themselves. And now we're putting them together. So what I would do if I were you is I would do this. Now what is this? What would this look like in our numeration system? 11 60s, and this is 13 1s. Now can you put those back together? Oh wait. Figure out what Hindu Arabic numeral that would be. Don't say it out loud. It's exactly like we did earlier. How many 60s do we have? How many 1s do I have? So how many 60s are in there? 11. What's 11 times 60? 660. And how many 1s? 13. So 660 plus 13, 673. So if you saw on a clay tablet a rundown of how many bananas they sold that month, and you saw these markings, you would know that meant 673 bananas. You with me? And if we grew up in this system and we were lucky enough to be one of the few educated people, because not everybody had access to education back in the day, for damn sure, but if we were lucky enough to have education, we would look at that and know it meant 673. Why did we have to do work? Because we weren't brought up in this shit. Right? So of course we gotta use, it's sort of like when you first learn another foreign language, or if you have to translate the frickin' metric. We weren't brought up in that shit. If I said, how big is a decameter? Can anybody show me? No, and it's not your fault. You just weren't exposed to it, so why would you know? Somebody semi with me? the math involved in this kind of problem is very minimal. In fact, let me say this. Anytime we're going from a different representation to ours, it will be relatively easy. It'll be multiplying and adding. So let me give you one more problem like this, and then I want to talk about going the other way from our system to theirs. That's where things get a little bit freakier. Oh, shite. Okay. So what about this number here? How many places are there? So go ahead and try it out. I'm going to go grab some more paper because I'm very smart. All right. Paper. So let's see. What place is this? Ones?
3600.
Cool. So I could translate to our numerals at least at first. I did that one for you. What's this one? 11, and this one is 3. I'm not sure what my fascination is with 1160s. So 2 3600s is 7200 plus 1160s we saw a minute ago plus 3. So you get
7,860.
kick ass. So this numeral, if you saw it written on a Babylonian tablet somewhere, it would represent 7,863. Crazy sauce. Now, if you think about it, this is not very efficient. It's not very easy. But my God, they were one of the first civilizations. So, I mean, they had to make this shit up totally. So every time we kind of saw, so that we could improve on it. Improve, and then you get to our system, which is pretty good. Okay. All right. So let's talk about going the other way. What do I mean by that? What if I gave us, let me start off nice, 89 in Hindu Arabic, and I want it to translate to baby, Babylonian. If there's any Babylonians in the audience, I'm sorry. I don't mean any disrespect. Just it's easier to write baby, so what do you guys, all right. There's two aspects to every numeration system. There's the numerals that you use, and if you have a place value, right? And what that looks like. So Babylonians have a place value system. I need to figure out how many places will it take to represent 89. You with me? That's my first step. So let me see if you guys are cool with this. Do I put 89 into the ones place? Okay, why can't I do that? Bigger than 59, right? The minute I get 60, I roll over into the next place. So I need you to see how that makes sense then. I start with the highest place that I need. What comes after 60 again? Is 160. Do I need 3600 for 89? No. So I try to tell my students when we're starting to do this kind of thing is go too far. So I need the ones place, I need the 60s place, The next one's this, that's too much. If you go too far, you know you went far enough. If you don't go too far, you might not have gone far enough. So it's very obvious that's too much. It's not that big. And if I start here, I can start to break this down. Yeah. Are you good? I'm sorry. Okay. How many 60s does it take to create 89? 1. How much do I have left over to take care of? And all those can go right there, yes? Yeah. But again, how much can they have in one place? 59. So now write that in Babylonian numerals. Here, I'll do the first one. Here, all right. There. Okay, now how do I write 29? I did this on purpose. How do I write 29? 2 less thans or 2 Pac-Men? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You with me? So if my number was bigger than 3,600, I would have started with 3,600, right? The next place, how would you figure out the next place after 3,600? Multiply it by 60, right? Okay. You always start with the biggest place, and then you see what's left over for the next smaller places. Does that make sense? Okay. Does anyone wish that they had invented a quicker way to write 29? You guys with me? So, one more symbol I'm going to show you. They had a symbol for subtraction. You guys all right? You guys are like, no, I'm okay, man. Don't show me any more symbols. No, it's too bad. I'm going to show you. Their symbol for subtraction is very simple. It looks like that. So in reality, it looks like a triangle with a triangle on top, yes? But I'm going to draw it like this. So instead of writing 29 like this, is everybody with me? That's subtraction. That would be what it would look like on the tablets. That's what I'm going to draw it like when in practice, when I'm writing on a piece of paper. So that means subtract. So look at how I could write this instead. I could write this as 1 and then 30 minus 1. It's a little bit cleaner, yes? You guys with me? I need to represent 29. So I can either do 29 or I can do 30 minus 1. So which one is the right answer? Yes. So whichever one you want to do, great. You understand that at some point they're about the same amount of work? So yeah, okay. So if you never want to use the subtraction, okay, but there are some problems in the homework where they have the subtraction symbol and you have to translate. So you do have to know what it means, but you don't have to use it yourself if you don't want to, for whatever reason. No, okay. Okay. So let me try a bigger number. Oh, you got paper, Jeff. Thank the gods. So what about the number 9,486? So let's see if you guys are starting to get the process without me actually having to list it out. So I'm going from Hindu Arabic to Babylonian. What's the first step? Go too far with what? Places. I like it. So the first step in these kind of problems is to figure out how many places I need. And you always go one too far. You don't have to, but I'll show you what I mean. So definitely need a ones place. What's next? 60s. What's next? 3,600. Can somebody tell me what's next? There it is, 216,000. Everybody agree that's too much? That's bigger than the number I have to do, so I don't need any of these, yes? So I've gone too far. So let me see if you guys can see how to do this. Now I know how far I've got to go. What do I do? Yes, good. Start with 3,600. How many 3,600s take care of a big chunk of that number? So I always think of it like, you got to make 9486. Well, how many 3,600? What can they contribute? 2 of them, because 3 would be over. So if I put 2 of these, and what we really just did was divide, sort of, right? I didn't really divide, but we saw that 3,600 goes into this about 2. And now what do? How do I figure out how much is left over for these guys? How much did we just create? So now I can see what's left over for the next few places, yes? I'm trying to construct that number. I got 7,200 of it set. What's left to be taken care of?
2,286.
Cool. Now, real quick, does everybody have your calculator out? I want to show you, all right, I want to show this. Anybody want to borrow a calculator? I got a big bag of them. And they're like the little non-intimidating ones, right? If you don't want to, it's fine. I'm not going to take it personal. But if you want to, I got some. What I need from you is an ID. I can't be as trusting as I used to be, unfortunately. Make sure this turns on, yeah. There you go. Okay. Everyone else is good? Okay. So do this for me. What is 2286 divided by 60? Because I got 2286, and I want to see how many 60s go into it, yeah? 38.1. I like it. So I definitely want 38 here. Now, couldn't you do... All right, let me see if you guys are cool with this. I really want to show you this shortcut. It's just so cool. What's the 0.1? What's the 0.1? I mean, no, not... But I mean, where did it come from? If I long divided this thing, what's the 0.1 all about? The remainder, kick ass. Isn't that what we want to know now? Is how much is left of the number? So, let me show you a shortcut, and then I'll show you the long way to do it, and you can pick. I'm going to take 38 away, because I already have 38 here, don't I? And then I'm going to multiply that by the number I just divided by. And that's the remainder. I'm sorry. Is that better if I do this? I got to get to a decent place. Is that better? Is that better? Is that better? Is none anything better? It's the glare. Is that better?
No.
That's worse?
Right there.
There?
There.
All right, wait a minute. All right, I'm going to use my graphing calculator because it's backlit for this. Okay. So let me do this again. Look at that! Okay. So let me do this again. So I got, what was it? I forgot what we did. 2286 divided by 60. All right, I like it. So when you divide, the remainder is going to be put over 60, correct? Does that sound familiar? You make a little fraction out of the remainder. So it kind of makes sense. If I just isolate the remainder and I multiply by what I divided by, I see what the whole number remainder was. So then I put a 6 here, because that's how much I got left. Now the longer way to do this is, I got 38 60s. What is 38 times 60? 2280. And that's 2286, so how much is left over? 6. And that's not that much longer, but I just want to show you the cool little, you can actually use the decimal part to get you the next step, or you can just multiply and then compare it to see what's left over. So if I take 2 of these, 38 of these, and 6 of these, I will make 9486, yes? Now why is this not the answer? Yet. Because I'm not in Babylonian yet, right? So how do I write 2 in Babylonian? What about 38? I'll take 2 different answers. I could do 40 minus 2, or I can do 30, 1, 2, 3, 4, 5, 6, 7. And then 6, I wouldn't use subtraction for 6, because you end up with the same number. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'd accept either one of these answers. You guys with me?
Can you just show that, the longer way, just one more time?
Sure. I'll do this sort of again. So I had 2286 divided by 60, and that's how we got this. I ignore the 0.1. It goes in 38 times. So what did I just take care of? I took care of 3860s, right? 3860s. And that's 2280, which means I have 6 left over. That's all you have to do, yeah. So I'm very sorry that I showed you the other way, but if some of you guys get it, it's kind of nifty. If you don't ever want to do it, don't. Let me stop for a minute. So just to let you know, in the Babylonian civilization itself, you would have seen either one of these. It was sort of a, you could use it or not. So we'll do the same thing. How you guys feeling? Feeling all right? Like, I don't know yet. Now here's the trick with the Babylonian system. They, at first, did not have a symbol for 0. Could there be numbers that require 0 of something? So for example, let me give a really easy example. Let me see if anybody can pick up. What about 3641? How would I construct that? What places do I need? 1s, 60s, 3600. I can see that that's where I should stop, yeah? That's okay. You don't always have to go one more, but just really make sure you go far enough. So this is easy, yes? How many 3600s do I need? 1. And what's left over? So how many 60s do I need? None. I need 41 ones. Everybody with me? So you guys are lucky. You were born at a time in a civilization that has a symbol for 0. Not everybody in history was that lucky. They did not initially have a symbol for 0. I think the book shows, but eventually they did come up with a symbol for 0, and then not too long after that, the civilization fell. Right, so there's one guy going, I figured it out. Oh, shit. Party's over. So how would I write this then? You would do 1, long-ass space, 41, and you would hope. And I think, let me see if I'm right. I can't remember this book shows you the symbol for 0. Has everybody got that? Let me see. This is 2, 2. Mayans have a symbol for 0. I think they do. Where is it? They talk about it right here. Do they give it? Barfy, barf, barf. Oh, it's in here somewhere. I gotta look at it. Oh yeah, there it is. There it is. Okay, I'm not sure where they put it here, but right here, this little dude. See the 2 triangles on top of each other? That's their placeholder symbol. That would indicate 0. I don't see where it is in the write-up though. Where's it in the write-up? Oh well, too bad. Too bad for us. Yeah, okay. So in this case, right here, I could put, how do I want to do it? Like a little triangle. And that would be a 0 in that place. Okay. This is really strange to us, because ever since you were born, the civilization you're a part of had 0. Had the idea of 0, and had a symbol for 0. So that's Babylonians. Babylonians, I'm going to make you memorize everything about them, because there's not a lot. What's their base value system based on? Their place value? 60. And their numerals is just 2, really. 10 and 1. Then you got subtraction if you want it, and you got a symbol for 0. So not a ton to memorize for Babylonians. I'm not going to make you, so I am going to give you Roman numerals, remember? I am going to give you Egyptian numerals, yes? I'm not going to make you memorize those. Okay. So let's talk about Mayans. Mayans have one of my favorite ones. I think, did I say something about Chipotle last time? Yeah, I did. On the walls of Chipotle sit the formal shapes of the numbers 1 through 20. They look like faces. I'll see what the book has them, I can't remember. But here's the everyday Mayan numeral system. They did have a symbol for 0. Oh shit, this book does it a different way than what I'm used to. Sorry. I'm used to, here it is. Yeah, I'm used to it being the other way around. So I gotta remember this. So they use this for 0. That means 0. I always think of that looking like a biscuit or a bun or something, like a, I don't know, hot dog bun or something. You guys with me? And again, if there's any minds in the audience, I mean no disrespect. I love it. So this means 0. 1 is a dot. You gotta love that shit. I call it a blueberry. You'll see why. 5 is a pancake. So we get pancakes and blueberries for the Mayans. So what's the name for this kind of thing? These are the whats of the Mayan system. Numerals. What else do I have to tell you? If they have a place value system, right? So let me ask you guys this. Did the Egyptians have a place value system? No. Good. They just drew the pictures and you added them up. If it was here, or it didn't mean anything different. So for a place value system to be in effect, if I put the 4 here versus over here, it means something different. Egyptians, they could do it whatever they want to and kind of tell a story as they represented numbers, if they felt like it. Okay. Mayans had a place value system. 2 things that were a little weird about it. Theirs goes up. Instead of left to right, theirs goes vertically. So the 1s, and then it builds from there. You guys with me? They had a base 20 system, sort of. And you're all like, damn it, can't any of these people? So again, what was one of the most important numbers to ancient civilizations? Because it roughly estimates something that's important to them. 360. So if you use base 20, if your base is 20, what's your places? 1s, 20s, 20 times 20, 400. Oh, they were like, no, we can't let that pass. I gotta shove 360 in there somehow, yes. So here's how they're placed. Watch this. So they did the 1s place, the 20s place, and just to show you, here, just to show you, because I feel some of you guys like pulling back like, screw this shit, but I will give you their places, yes? I'm not going to make you memorize what I'm about to tell you. 1s, 20s. This is not 20 times 20 like it would normally be. This is actually 20 times 18, because what's 20 times 18? 360. And then they continued with times 20. So this one place, they shoved 360 in. And then they kept going by 20. What's 20 times 360? What's 2 times 360? 720, and then tack a 0 at the end. You guys with me? And then they keep multiplying by 20 forever. So it's almost a base 20 system. Just has this one little place that's off kilter. Let me let that sink in for a second. One semester I said that a lot, and somebody put the little picture of a sink, let that sink in on one of their assignments. I'm like, I appreciate that. Call me out if I say something over and over. So let's start the easy way. So this kind of sucks. But let's see. Let's try the easy way. And what I mean by easy way is if I give you a Mayan numeral, can you translate it back to us? It's always easier to come back to us. So Hindu Arabic. Let me give you an example. Here we go. Oh, by the way, I'm sorry. I should really do more with this. What do you think this number would be? Exactly. What do you think the most number of dots I can use? Because if I do one more, it becomes a blueberry pancake, right? So 4 would be 1, 2, 3, 4, but 5 is a pancake. So how do I write 9? Say again? 4 blueberries and a pancake. Isn't that 9? What would 10 be, though? 2 pancakes. Okay, you guys start to see how this kind of gets put together? Okay. I like it. So what would this be? Let me give you a Mayan numeral. I want it to go to Hindu Arabic. Did a big space there, but don't over analyze that. How many places do you think there are? Do you guys see there's 3? 1, 2, 3. Yes? This isn't all in one place because you don't stack blueberries on top of blueberries because that's insane. It's never going to stay on top of the other blueberries. It's going to roll off. Okay. What do you think my immediate next step is? It's the same thing we did with Babylonian. We identified 3 places. Now what value is each one of them? What's this value, this lower one? Ones. 20s. 360, good. So how many 360s do I have? 1. How many 20s do I have? 6. And how many 1s do I have? 3. So even though this is oriented a different way, their bases don't really follow the rules like they did before, it's the same math. It's exactly the same math. Translate the numeral into our numbers and then put the number together. I have 1 360 plus 6 20s plus 3 1s. Right? So what number would that be?
483.
Yeah, so 6 20s is 120 plus 360 is 480 plus 3, 483. So if you were an educated Mayan back in the day and you saw this on a piece of paper, or a piece of paper, whatever they used, to be really honest, I don't know, I think it's papyrus, you would know that that meant 483. How are you guys feeling right now? I mean, if you understood the math from Babylonians, this is the same exact math. Different numerals meaning different things, but I can see how many of each thing I've got and then put it back together. Let's do another example. And tell me where I'm losing you if I am. You lost me at hello, yes.
Just why is it vertical?
Say again?
It's vertical instead of.
It is.
That's what's tripping me up.
Totally. Who else did things vertically? Chinese. So the ancient Chinese numeration system goes vertically. And it's really cool. There's a homework problem about there, so I'll let you guys discover that on your own. But yeah, okay. Real quick question. No thing. If you don't like that it's vertical, create a time machine. Go back, talk to them, see what they say. They're not going to know what you're talking about, so then you have to learn Mayan first. It's going to take a long time. Okay. So what if I gave you this number here? I'm sorry, I just love the Mayan number. I mean, look at that. That's a freaking number. It looks like a little story. How many places are involved? 3. All right, get as far as you can with translating that into Hindu Arabic. Oh yeah. How many 360s do I have? 3 360s. How many 20s do I have? None. And how many 1s do I have? 16. So 3 times 360 is 1,080 plus 16. 1,096. Cool. So this numeral in Mayan represents the same thing that this numeral represents in Hindu Arabic. 1,096 things. So please, if you have trouble with this, can you identify where it doesn't make sense? Is everybody cool with the numerals themselves?
No, I'm confused. I'm just confused at the bottom where the 16's coming from. Like it's
Oh,
3 to
okay.
16,
Each
like,
pancake is how much?
Each pancake is
5. 5, 10, 15,
Oh,
blueberry, 16.
16. Oh.
Each pancake is 5, each blueberry is 1. Okay, cool. Okay. Go ahead. What's up?
Because it has already 2 pancakes and doesn't have and add 1 to 5.
So, sorry? So everybody needs to understand this is one place, correct? Okay. So there's 3 pancakes, they're each worth 5, and 1 blueberry is worth 1. So this by itself is 16. The fact that it's at the bottom means it's 16 ones. This is 0, so no 20s. 3 blueberries is 3. It's at this position, which is 360, so there's 3 360s.
I got that. And I was gonna ask a question about the one earlier about
Oh.
43. I understand how you got 43, but did you like just do random? Like, I'm just confused on how. Did you just start marking those and then you got 43, or like how? I'm just confused.
Yeah, I just made this without knowing what the number was
Okay,
going to
I
be.
was wondering where.
Yeah.
Okay.
I just I thought blueberry and then pancake blueberry. I had no idea what the answer was going to be ahead of time.
Okay, that's
0 idea. I am not a mind. I'm able to do math really well, but if you showed me this out of nowhere, I would have no idea. I'd have to stand there and go, think about it, right? Is that so? I didn't make the problem knowing what the answer was going to be. We both got to the answer at the same time.
That. Okay.
Yeah.
I was thinking. I didn't know how you got that. I know you got the answer. I was just like, where is that?
Yeah, I didn't make it this. It just was this.
All right.
Yeah.
That's cool. All right.
How's everybody else doing? Okay, good. The minute I lose you, stop me. Do not let me steamroll you. Don't look around at everybody else and they're going like this, because a lot of those people are lying to me. So don't feel like you're going to hold anything back. Have I said this yet? It's my job to manage the time in here. It's not your job. Your job is to ask questions and to mull over what we're talking about. My job is to keep us on track. So if I get a bunch of questions, at some point I would go, okay, we got to move on. Anybody still see me after? You with me? So there's no reason, I'm not sure how to say this correctly, but there's no reason to self-censor in that aspect. Please do not self-censor, don't say weird ass shit, but there's no reason to stop yourself from asking questions because you're worried if it's going to hold me back. That's my job. You with me? So ask questions. All right, so with that in mind, I want you guys to do some of this on your own. As much as you can. So guys, I know you're not quite done, but I want to start to try to catch up to you a little bit. You'll notice that, does everybody in here draw a 4 the same way, do you think? You guys know that not everybody draws a 4 the same way. So there's a little leeway with how the symbols are drawn, but you'll always be able to tell what it's supposed to be. So those first 2 symbols for Egyptian, do they match what I have at the bottom here? And does this match what's in the book? No, but they all are a little flower in a pot. Yes? So what does that represent? Each flower is how much? 1,000. So that's 2,000. 332. Shabam! Okay. What about this one? This is obviously, I'm not going to tell you, but you can tell that what system is this? Babylonian numeration systems. This is going to be the ones place? 60s. How many is in the ones place? 24. How many's in the 60s place? 31. So I have how many 60s? 31 60s plus 24 ones. 31 60s is 1860. Sounds like a history test. Plus 24, which is 1884. And I know something must have happened in 1884, but I teach math. What do you want? Somewhere there's a history teacher. Just come on, Jeff. All right, are you guys okay with that? So just think back to before today. You're like, I was fine, Jeff. Before today, I was fine. I didn't need to know my. All right. By the way, I want to say this real quick. Depending on the level of of school you teach. Sorry, I'm a math person. You with me? You might actually be teaching these systems to students, but what if you teach like first grade, kindergarten? What is this doing for you? Do you have any idea what going through this is doing for you? Yes. Perfect. This helps you relate to them. According to them, our system is freaking foreign. Holy shit, we're not, unfortunately you can't just, plug in and go, I know base 10, right? There is no spoon. Right. You can't do that shit, right? There you go, somebody got my reference. Right. So yeah, perfect. This is exactly, so some of the stuff we're gonna do in here is gonna be directly, you're never gonna teach the students it, but it's just supposed to help you realize how it feels for them to learn what they will be learning. The more you feel that way, the more you can empathize with them. You can adjust how you're teaching because you understand what's going on with them, right? Okay. So how many places are involved in this numeral here, these numerals? 3 places. What's this bottom place? 1s, 20s, 360s. How many 360s do we have? 3. How many 20s do I have? 8. And how many 1s do I have? 17. And then I just have to put that number back together. Right? So I get 1,080 plus 160 is 1,240? 1,257? Thank you. Okay. Pretty good numbers, but it's good to have validation. Let me slow down a bit. Is everybody with me? And do you notice this is what I've tried to do with each of you that were very lost is to show you this is all brand new shit. You've never seen this before. So let it kind of soak in for a bit. So you're going to have to kind of remind your students, this is brand new. We're going to look at this. You're going to become more better. Now I'm showing up the history and my grammar. You're going to become better with this stuff over time as you do more with it, right? Ain't no way you're going to understand something completely at 20 minutes after you first saw it in your entire life. Holy shit. You got to work with it a little bit. So what do I look for first in Roman numerals? What do I look for very first thing? Is this a place value system? No. Where I put the M, it has to be a certain order, but just because the I is there doesn't mean something different. That means 1. What do I look for first, though? Pairs. Good. Pairs that are what?
The last one is first.
Yes. So the smaller symbol is first because that means subtraction. Everything else in Roman is addition. So I see those. Where else? XL. I like it. So M is 1,000. CD means 500 minus 100. 400. XL, 50 minus 10. Are you guys with me? All right. Those of you listening, are you? Okay. 40. And then, of course, VII we know is 5 and 2 is 7. So you get 1447. Again, another year in history that something happened. You probably, if I'm going to make a guess, Egyptians are nice, especially because I'm going to give you the symbols. So Egyptians, you're like, give me a lot of Egyptian stuff, Jeff. So I'm not going to. Romans maybe is okay, but it's a little bit tricky. And then these two are like, okay. But these two are better, hopefully, now versus earlier. So let's look at this one, Egyptian. So Egyptian is purely additive. How many? I need 4 whats? Yeah. I need 4 squiggles. 4 squirrels. 1, 2, 3, 4. And then I need 8 heel bones. I like it. 8 half birds, because I make a bird like this. That's a bird. So 8 half birds. 1, 2, 3, 4, 5, 6, 7, 8. And then I need 7 staffs. 1, 2, 3, 4, 5, 6, 7. Okay. So Egyptians, let them be nice. What about Roman? Oh shit. So the way to look at Romans is this. 487 is 400 plus 80 plus 7, yes? That's what we call expanded form of a number. Now I can figure out, okay, what requires subtraction, what requires addition. 400, guys, 400 would require what? Can I use CCCC? No. What do I have to do instead? Yeah, CD, I have to use subtraction. I've got to do 500 minus 100 because I can't use 4 of the same symbol in a row. So this will be, where'd it go? CD for 400. How do I write 8? Just 8. I know it's 80, but how do I do 8? How do you write 8 in Roman? No, 8. Just 8. V, I. Yes? So 80 should be 50 plus 10, 10, 10, the same way. What's 50? That's what you're trying to tell me back there. I'm sorry. 50 is L. And then 10, 10, 10. X, X, X. Cool. And then 7, you know, you knew before even you took the class. 7 is VIN. Let me stop for a moment. Do y'all agree it's easier if I give you the Roman? Yeah. So what you can do real quick, if you have time, is just change this back without looking at it. Change it back. Make sure it actually goes back to before 87, right? Okay. And then finally, the 2 other ones we just learned, Mayans. How many places do I need? What are the places?
360s,
360.
So we got 1s, 20s, 360. The next one would be 7200. I don't need that much. Okay. So how many 360s do we need? Just 1. And how much is left? 127 is left. So I'll put over 487 minus 360 is 127. How many 20s do I need then? 6. 2 goes into 12 6 times. So I need 6 20s. Why did I put that in parentheses? It doesn't matter. 6 times 20 is
120.
120, so I have 7 left, and I just shove all that there, right? Let me stop for a minute. Okay. So I'll write 1 in mine. Blueberry. 6. Pancake, blueberry. 7. Pancake, 2 blueberries. So I feel like we work in a breakfast place. I got an order for 1 blueberry. Who's this person? All right, let me stop. So the math involved. Are you starting to see? I know we get stuck in the symbol and we get stuck with why do Mayans have to do this? The math involved is exactly the same in every place value system. And that's why this is worse, because this is subtraction and division. This is easier because it's multiplication, addition. So what about, oh sorry, I gotta do baby. How many places do I need for baby? I'm sorry.
61.
I need 1s, 60s, because the next one will be 3600, which is bigger than the number. So how many 60s? 8, and then I have 7 left. Is that cool?
Yes.
Okay. So baby would be, you could do this, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Or 10 minus 2, 10 minus 3, right? I'll take either one.
I'm glad you take both, because honestly for me, I don't know, it's just easier to do it might seem more like what I'd rather write.
You're fine. I mean, don't blame me. And again, there were Babylonians, some didn't do it at all, and that's fine. It was accepted. It's just a shortcut you can use if you don't want, if you want to, if you don't want to. Okay. Okay. 4,962. Damn you, Jeff. So Egyptians, I need 4 what? What do you call it? Tree hugger. Alright. So 4 of these guys. 4 lotus flowers, or tree huggers. You can have the facing whatever way you want to. 2, 3. And you can do really crappy picture like me. Good lord. It looks like the little Pixar lamp. 900 would be 9 scrolls. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not scrolls. No secret wars going on. 60. So I need 6 whats? Heel bones. 1, 2, 3, 4, 5, 6. And then 2 staffs. Okay, Egyptians. Oh, yes.
Can we not make it all in one long?
Totally.
Okay.
You have as much creativity as they did, which is infinite. You could, as long as it's kind of like somehow contained, you could do it. So what they did was, this would live in a little section. Hello? Yes.
Do we need to know what they're called? Like if
No, I love it. So
swirl or like
this is a really interesting point. Like if you think about it, how the hell did the Romans say the numerals? They didn't. It wouldn't be like no. So they each had a word, and it's obviously Latin and so forth, right? But then you think about Egyptians. How did they speak this to each other? You with me?
Right.
So they had words, but it didn't really necessarily match how they did their numerals. So they had words for 4,000, but they wouldn't say the same word 4 times. Does that make sense?
Yeah.
All right.
So that's
No, it's been forever since I looked it up, but now maybe I will look it up. I always forget to do that.
Matter if we just say swirl or scroll or like whatever.
Oh, I see. There's no way we could really know. So when you see there that it's called a scroll, well, they know from context. So the staff, they know from context, it was picked to represent one, and they know it was supposed to be a staff. Heel bone, they know it's supposed to be heel bone. Scroll, they know it's supposed to be a scroll. Yeah, you can pick that up from context of other things that were done with these symbols. You with me? But I thought you meant like how would they say it? They obviously didn't say scroll because that's freaking English. So, right? They're not. Yes, but I don't know what they would say. To be honest, yes.
By heel bone, do you mean like the bone in your heel?
Totally.
Like,
What it looks like?
No.
so they were seeing like that many of them?
Huh?
They were seeing that many of them that they chose it to be one of their.
Well, they saw their heels,
Well, you
right?
get to the bone.
And you can think of it. It looks like a horseshoe, right? It looks like a horseshoe.
I just
But that's not what the heel bone looks like. If you've seen it, it kind of looks like something that could go around your heel. You with me?
Yeah.
Yeah. So obviously they actually the other way around. They didn't see many heel bones from it. I'm sure they did, but they didn't think about it. Okay. Let me see here. Okay. Romans, countrymen, lend me your ears. So we already talked about 4,000. So anything above 3,000, I can write the number with the line over it. That's 4,000. What about 900? It can't be DCCCC. Why not? Too many C's. CM. Why is that legal? Because I can subtract something that's 2 places below something else. So I can subtract 100 from 1,000. So that's 4,900. 60 would be LX, and then 2.
Yay.
And then, let's see, Mayans. So 4,962. How far up do I have to go? 1s, 20s, 360s. The next one would be 7,200, right?
It's too
Too big. So now you do 360 into 4,962. You can do that in your calculator. What do you get? 13. And then how many do you have left to take care of? Yeah, what's 13 times 360? 4680?
Yeah.
So then you have, holy crap, Jeff. Then you have 282 left? 2, oh, jeez, I can't read my own writing. 4962 minus 4680. There we go, buddy. 282. Yes, okay. So how many 20s? 14. 2 goes into 28, 14. So that's 280 and then 2. Okay. All right, so then I can make this into Mayan. 13 would be?
3 blueberries.
Yeah, 2 pancakes, 3 blueberries, 2 pancakes, 4 blueberries, just being indulgent. And then the person that's, I just want 2 blueberries. And then they eat my pancake, whatever. All right, you guys go to, okay, just let me have some of your pancake. Oh. Yes?
Can you move the paper so I can see the numbers?
Maybe. Okay. Yes?
For the Roman, I did the M before the 5,000. So could I do that like 5,000 minus 100 and then just do the
Minus 1,000. But no, you don't need to for one thing, right? Because you can just make a 4 and put the line over it. So that's not the way that worked. Yeah. Okay. This is running a little long. I'm sorry. I want to let us out earlier, but Babylonians. Very quickly, it would be 160, 3,600, right? You'd use one of these and you'd have 1362 left. Yes? And then 1362 divided by 60. What is it? 22? So what did I say? 1362 minus 1,200, 1320, I believe. So you have 42 left. Yeah? That's all I know is math, so I want to show off something. So they have 1, 22, and 42. All right, 42, of course, is the answer to life, universe, and everything. All right, guys. Sorry, I wanted to. That's enough. So our first quiz is next Tuesday, a week from today. 2-1 and 2-2. I'll never give you a quiz on something the next day, the day after we learned it. So.
And then you do suggest having all the evidence by the class, civil starting on the so you can look it over.
Yeah, you should